We are moving on to polygons, and in geometry, we know that polygons are two-dimensional figures made up of line segments, and when we look at those polygons, we get a whole bunch of angles. So today we're going to focus on interior angles of polygons and exterior angles of polygons. So let's take a look at this triangle. It's easy for us to see the interior angles because they're inside the polygon, and we know that a triangle has three interior angles, and those three angles always have to add up to 180 degrees. What most people don't realize though is all polygons also have exterior angles. If we extended a line out from this vertex right here, we can see that we get another angle that's formed. And we could do that to each of the vertices and we would get more angles. So when we are going to find the interior angles of polygons, there's a rule that we can use for that. Now, you don't have to just memorize. We pretty much memorize that the three angles of a triangle equal 180 degrees. And most people know that all the angles inside regular polygons should be equal to some degree measure, but we don't remember what degree measure it is. Well, there's a rule for us to find those degree measures, and the rule is based off the concept of the triangle. So the rule is n minus 2 times 180, and n is the number of sides of a polygon. So if we took our triangle, it has 3 sides. And if I subtract 2, what's happening, when I subtract that 2, it's telling me how many triangles are inside that polygon. So when I multiply the one triangle times 180, that's where I get my 180 degrees for a triangle. Now, let's say we have a square. Well, a square has 4 sides, and I'm going to subtract 2 from that. The reason why is when I subtract that 2, it now tells me I have 2 triangles that can be formed inside that square. Well, each triangle is worth 180 degrees, so 2 times 180 is 360 degrees. And I can do that with any regular polygon. So let's take a pentagon, which is a 5-sided figure. It has 5 sides. I subtract 2, that tells me how many triangles. And here I can see my 3 triangles that were formed. And each triangle is worth 180 degrees. So the interior degree angles of all regular pentagons are 540 degrees. And if I have a hexagon, I take my 6 sides of it, subtract 2, it tells me I should be able to form 4 triangles inside that hexagon. Here they are. And each triangle is 180 degrees. So if I multiply it by 180 degrees, that tells me 720 degrees would be the degree measure of any hexagon. Now, because we are looking at regular hexagons, if I take that degree measure and I divide it by the number of sides, it tells me exactly what each interior angle would be. So if I take 180 degrees and I divide it by that 3 sides, I get 60 degrees. So I know that this angle has to be 60 degrees, this has to be 60, and this has to be 60. And I can do that with any regular pentagon. Regular meaning same side lengths, same angle measurements. So if I had 360 degrees and I divide it by the 4 sides, I get 90 degrees, 90 degrees, 90 degrees, and 90 degrees. And because they're regular, they have to be the same degree measures. So each angle of a regular pentagon would have to be 108 degrees because I'm going to take 540, divide it by the 5 sides. Each angle of a regular hexagon has to be 120 degrees because I'm going to take 720, divide it by the 6 sides. That gives me 120 degrees. And I could do this forever and ever and ever because there's an infinite number of different polygons. So that's our interior angles. But we also have exterior angles that formed on each of those polygons. So if I take a look at this triangle, I can see that I have 3 exterior angles that are formed. And there's a rule for exterior angles too. So the rule is if you add up all the exterior angles of any type of polygon, they should equal 360 degrees. And the reason why is because if I take angle 3, add it to angle 1, add it to angle 2, it actually creates a circle, which is 360 degrees. So it doesn't matter the kind of polygon that you have. If you take those exterior angles and add them up, they have to equal 360 degrees. So say we have this figure, different than my triangle. This looks like a parallelogram. Well, I have 4 exterior angles. I already know that if I added all 4 of those exterior angles together, they have to create a circle, which means they have to equal 360 degrees. Now, they don't have to tell me all the angles. Sometimes they're going to give me variables in my angles. So this angle is x degrees, this angle is 89 degrees, this angle is 2x degrees, and this is 85 degrees. And I'm just going to create an equation for that. So x degrees plus 89 degrees plus 2x degrees plus 85 degrees has to equal 360 degrees. So I'm going to gather my like terms. So x plus 2x equals 3x, and 89 plus 85 equals 174 equals 360 degrees. Now we're just down to a 2-step equation. I'm going to subtract 74 from both sides. I get 3x equals 186. I divide both sides by 3 and I get x equals 62. So I know this degree measure has to be 62 degrees. This is going to be 2 times 62, which is 124 degrees. And if I add those 4 angle measurements together, I know they should equal 360 degrees. And if they do, then I know that I did that problem correctly. So interior angles, exterior angles. Both of them are fairly easy to figure out what our angle measurements are, and we don't need to use the protractor. So it's your job now. Good luck.